Let me pick up where I left off on our quadratics review for our unit test. I'm going to factor these trinomials into the product of two binomials. I have a negative sign and a positive sign. It means it had to have been the product of two negative numbers. Factors I could use would be, I got negative 12 times negative 2. That sum would be negative 14, so there's no way that's it. 6 and 4, negative 6 times negative 4. Their sum would be negative 10. That's it. Minus 6, minus 4. Of course, I'm supposed to make it easy. Look easy. X. I got a minus minus. It's going to be a minus plus. 18 and 1. If I have a negative 18 times a positive 1, negative 18 and 1 is going to give me the sum of that negative 17. Number 12 I'm going to recognize as the difference of squares. Difference of squares pattern tells us that the product is the sum and the difference of the square roots of each of the factors, of each of the terms. 7 times 7 will give me that. Negative 6, I'm actually not going to deal with a negative, I've already dealt with it. 16x squared would be 4x times 4x. Difference of squares pattern. Moving on to solving. Solving means I'm going to find the x-intercepts or the values when y is 0. A lot of that, often that is relevant to solving problems like launch and landing type of problems. To complete this square, I'm going to use the method where I open up parentheses and move out the constant that's there. I'm going to look at the 14, that's the middle term, and as we've practiced, if we take half of that, if we take half of 14, we wind up with 7. We want to pick up that 7, square it, and add that to create a perfect square trinomial. Perfect square trinomials, this is going to be p plus 7 times p plus 7. Now the fact is, let me get back up to where I was, the fact that I added 49 to this equation means that I actually need to come out here, and since I added 49 here, I need to subtract 49 from 38 in order to keep my equation in balance. Negative 39, Sadie, would you bring me a calculator please? There's one over there. Let's see here, negative 50 and minus 38, negative 87, I think this is negative 87, yeah, I'm pretty sure. So what I'm going to have then is, this is minus 87 equals 0. Just want to double check that. Multitasking right now. I'm totally questioning my mental math. Yeah, it was negative 87. And then I'm going to rewrite it as p plus 7, all that squared, minus 87 equals 0. In order to solve it, I'm just going to go through in the process of solving now, and I'm going to use square roots to undo this. The quantity p plus 7 squared equals 87. When I take the square root of both sides, I'm going to get p plus 7 equals plus or minus 87. I think 87 is prime. I'm going to check a couple. I think 87 is a prime number. 9 doesn't go into it. Sadie just said in the background it is. So I've got radical 87, can't be simplified. P equals negative 7 plus or minus square root 87. So my two roots are negative 7 plus square root 87 and negative 7 minus square root 87. Solving by factoring, when you can have a nice factor and you don't have a nice factorable quadratic and you don't have to complete the square like I just did on 13, remember that if I have two quantities that when multiplied together equals 0, then one of the two quantities must be equal to 0. So I'm going to set each of the quantities equal to 0 and solve. I'm going to subtract 5 from both sides. 4k equals negative 5. I'm going to divide both sides by 4. K is equal to negative 5/4. I think that's negative 1 1/4, subtract 1, k is equal to negative 1. So my solutions or my roots, ooh, that was out of focus. My solutions or my roots are negative 1 1/4 and negative 1. I'm going to move down here to number 16, just because I slid my paper this way. If I'm going to use the quadratic formula, I have to have the set equal to 0 before I identify my a, b, and c. So if I subtract 4 away from both sides of this equation, I'm going to wind up with 4b squared plus 8b plus 3 equals 0. That's resulted from that. My a value is 4, my b value is 8, my c value is 3. And in the quadratic formula, I'm going to use negative b plus or minus radical b squared minus 4 times a times c all over 2 times a. X-intercepts are going to be equal to plus or minus radical 64 minus 4 times 4 times 3. I think that's 48. 4 times 4 times 3. I was right. All over 8. Keep simplifying step by step. It's easy to lose your way here. 64 minus 48 is 16. I like how this is going. I'm going to get a nice pair of integer answers. Negative 8 plus or minus 4 all over 8. So negative 8 plus 4 divided by 8 is negative 4, negative a half. And negative 8 minus 4 divided by 8 is negative 12 over 8 is negative 3 halves. So my solutions here are negative 1 half and negative 3 halves. Okay, got that all squished up in there. Solve using square roots. Cool. Going to add 3 to both sides of this equation. 9r squared equals negative 149. I'm going to divide both sides by 9. And I'm going to leave this fraction the way it is here because I know I'm going to have to use square roots to undo. So r is equal to plus or minus radical negative 149 over 9. When I want to simplify this, I'll move around a little bit here. Plus or minus radical negative 149 over radical 9 plus or minus I radical 149 all over 3. Factored out negative 1 times 149 and simplified radical 9 to 3. There you go. I'll pick up where I left off in a few minutes.